Hello, my name is Woody Lee and I'm a research assistant here at the Smithsonian Marine Station at Fort Pierce. For the last several years, I've been assisting our marine science educators and students in our summer camp program how to build underwater robots, or ROVs, or remotely operated vehicles. This year, because of the COVID-19 pandemic, we can't have in-person classes, so what I would like to do is to teach you how you can build an ROV at home. These ROVs are very similar to the Scout class of the MATE-ROV competition. MATE stands for Marine Advanced Technology Education. And with a few modifications, your robot would be able to compete in the MATE-ROV competition. I'm going to show you what you're going to need in the way of PVC pipe and PVC fittings in order to build your ROV. Now, PVC pipe comes in several different thicknesses. This is 1/2" PVC, both these are 1/2". This one is called Schedule 40. This is your normal thickness for 1/2" PVC pipe, and then this is thin wall. If possible, please get thin wall because it'll make your ROV lighter and easier to maneuver. Now, you're going to need to get a 10-foot length of PVC pipe, and you're going to need to cut it into different lengths. This is a tool I highly suggest. It's called a PVC cutter, and it's a ratchet, and it makes a nice clean cut whenever you cut the PVC pipe. You can use a saw, but it makes the edges very frayed, and it makes it harder to fit into the sockets of the fittings. So once you get your 10-foot length of PVC pipe, you're going to cut 2 pieces that are 20 centimeters long, 2 pieces that are 15 centimeters long, 2 pieces that are 12 centimeters long, 8 pieces that are 10 centimeters long, 3 pieces that are 7 centimeters long, 4 pieces that are 5 centimeters long, and 7 pieces that are 3 centimeters long. You're also going to need a very short piece of 3/4 inch PVC. This is thin wall, but if you can't get thin wall, just get the regular Schedule 40. But you're going to need 2 pieces that are 5 centimeters long, or the 3/4 inch PVC pipe, and one you're going to cut a slit in like this. Now, these are the PVC fittings. Now, whenever you go to Home Depot or Lowe's, you're only going to get white fittings. I painted mine different colors so that makes it easier to see whenever we build the ROV. In the video, you'll be able to see what the parts are better. This is a 1/2" 90-degree elbow 1/2" PVC, and it's socket by socket. You're going to need 9 of these. This is a cross. This is a 1/2" PVC cross, and it's socket by socket by socket by socket. You're going to need 2 of these. This is a 1/2" PVC T, and it's 1/2" by 1/2" by 1/2", socket by socket by socket. You're going to need 9 of these. This is another T, but you're only going to need 1 of these. This T is 3/4 by 3/4 by 1/2, and it's socket by socket by socket. You're going to need 2 of these. This is a 3/4 inch PVC cap, and it's a socket. And this is another T. You're going to need 3 of these. This T is 1 1/4 by 1/2 by 1 1/4, and it's socket by socket by socket. And what I did here is I wrapped a piece of tape right around here and one around here, and then this is the neck for the 1/2" socket right here. And then you're going to need a saw to cut down along here and cut down along here. You're going to need to use a saw. You can't use the PVC cutter because it's much too thick. And when you cut it, you're going to end up with something like this. And again, you're going to need to have 3 of these, and I've painted mine red. Okay, so now that we have our parts all together here, let's start assembling it. So we'll start with the front. Put a T here, the 1/2" T here in the front, with the middle pointing up. 2 10 centimeter pieces on the side, and then 2 elbows. And these are horizontal, facing backwards towards what's going to be the back of the ROV. Put in two 3-centimeter pieces in the elbows, one on either side, and then put in another T, but this time with the middle part of the T pointing straight up. And you notice that these will close up. There's no gap in here between the elbow and this T right here. Then you're going to stick in a 5-centimeter piece into each one of those, again pointing towards the back. And then we're going to put in another T, but this one's going to be angled out 45 degrees. So the one on the left is going to be leaning to the left, and the one on the right will be leaning to the right. Then we will put in two 12-centimeter pieces behind that. Followed by two elbows that are going to be pointing towards each other. So the one on the left will point to the right. The one on the right will point to the left. And then each one of those gets a 10-centimeter piece of pipe put in. And in the center will be going a T. Okay, now we're going to get our mallet and we're going to persuade it to go where we want it to go instead of where it wants to go. Okay, so that's sort of the bottom's done. Now we're going to put in two 15-centimeter high pieces of pipe right in here. So they go vertical. And then in the back here, we're going to use a cross. There's going to be a 5-centimeter piece put in the bottom. And the cross is going to be pointing towards the front. One arm's pointing towards the front, the other one's pointing towards the back. And then on top of that goes a 7-centimeter piece. On top of that goes a T. A T goes here, pointing front to back. Another one on this side, also going front to back. And then the two 20-centimeter pieces go here. One goes on this side. One goes on this side. One elbow points towards the T in the back. And the other one points towards the T in the back from the opposite direction. Two 10-centimeter pieces go in the back here. One goes on this side, a matching one on this side. And then here in the front, two of the 3-centimeter pieces go here, one on the other side. The elbows point towards each other. And then in the center is going to go this cross. Two 10-centimeter pieces on either side. Okay, slightly tap everything. A 5-centimeter piece, no, 7-centimeter piece goes here in the center with an elbow pointing forward. 10-centimeter piece goes here, and then the motor mounts go on. This motor mount, these go in the 40, and the T's are pointing at 45. And you tap it in, again, it goes closed so there's no gap right there. This one gets tapped in here. And this other one already has its 7 centimeter piece on it. That goes here. This is for the vertical thruster. And in the back, this is for managing the cable. This is the T that has the 3/4 inch by 1/2 inch. That also gets a 3 centimeters, so that's going to close up so you can't see it. And then these are the 3/4 inch pipes, and these are 5 centimeters long, each one of these. The one without the slit goes in the top with the cap, and this one goes with the slit, goes facing towards the back right here. This gets inserted here. And the cap goes on it. And that's roughly the PVC frame right there. Just sort of encourage everything to go where you want it to go. And that's the PVC frame. From here we'll mount the motors, and then we'll go ahead and start working on the electrical system. This is going to be a mount where you can put a camera here so you can look forward, and you're going to make a camera. You can make a camera so that will work underwater. It goes to a TV set, or you could get it to go to a computer. And from this we'll be putting a hook on the end so we can actually do some tasks that are underwater. So that's the PVC frame for the ROV. Okay, the next thing I want to do, I want to talk about working on this, what I call the tool post area. Now, one of the great things about using PVC and PVC parts is you can make all sorts of changes. This is using an elbow right here, but you know, if you want to change it, you can change it to a T, you can change it to a cross, and you can put all sorts of different, what I call tools on the front. But for this one, we're going to use a wire hanger. And I've already cut the pieces, and these are pieces I cut out of it. And we're going to put a couple hooks on the front for as a tool for doing some things in the water. So I have a hot melt glue gun here behind the table. I want to squirt a little hot melt glue in the hole, and then put these hooks in it. These hooks they're about 15 centimeters long. And I'm using a rubber stopper. You can use corks or a wood dowel. This is just what I had handy. A little bit of hot melt glue on the cork, on this rubber stopper I mean. Shove it in, and I'll clean up this a little bit later. But now this is what we're going to be using for whenever we put this in the pool, in the kiddie pool, and then do some experiments. Okay, what I'm going to show you next is how to mount the thrusters onto the ROV. And what we're using for thrusters are these bilge pump motors. They're cartridges. This is at 1,000 gallon per hour. This might be a little bit too powerful for what we're going to be doing with this sized ROV. But you can buy 500 gallon per hour off of Amazon, or you can also get those from the MATE organization as well. And I'll have the MATE information sometime later. So these are where the motors are mounted, and this is actually a 1 1/4 inch T with a 1/2 inch receptacle at the top, and these are all socket. It was called socket, nothing's threaded. So with this particular one, you see this blue tape right here, we have to cut the sides down. So I put this blue tape here, and I used a bandsaw to cut this. You can use a handsaw, but I had a bandsaw available. And then you end up with something like this. Now I painted all these different parts, different colors, so whenever you look at the picture you can see what these parts are. So this is the what would be the thruster for going up and down, and this one mounts here. Now these thrusters if you put it in here to hold it, it's a little bit loose. And so if you take a 7-centimeter piece of masking tape, put it there, and then it will slide on, and it's held secure. Now you need to remove this blade right here. So using a screwdriver, you just pry that off. And this is, I believe this is an 1/8 inch shaft, but there's also a flat spot on it. You can buy these props. You can buy these props from MATE, and you can get them in a kit of 3. And with this one, to mount this on this, is that there's an indent right there. That's going to face the shaft. So this will, you screw this in until it bottoms out. Then this nut goes on. With the star washer, it's going to be facing towards the motor. And this is a 3/16 wrench. Just snug it up. And this is a shaft adapter. So then this will screw in. One end has a small hole will go on that. The other end's tapped. You put this on. Hold it with the wrench. Tighten this, and then use this as a stop nut. You just tighten this just a little bit to firm it up. And there's a set screw here, and then there's a flat spot. I don't know if you can see it on this shaft. So you want the set screw to fit right over top the flat spot. And then there's a tiny little Allen wrench. Do not lose this wrench. And then you tighten it up. And then once tight, you slide it in there, and this motor's mounted. Now I'm going to do this. I just showed you the first one. The other 2 motors will get done the same way, but with the shaft, the propellers will be pointing this way. So that's how you mount the thrusters into this ROV. So here pretty much is the completed frame for the ROV. And I've put the measurements of the pieces of 1/2 inch PVC on the frame. So as I rotate it, you'll be able to see it. And wherever you see a yellow and a blue together, or a blue and a red together, there are 3-centimeter pieces there. So this is pretty much the finished frame, and then after this, all we need to do is the electrical system. These number right here, these are all 1/2 inch PVC parts. This is a strange T where it's 3/4 by 1/2 right there, all socket. And these are 3/4 inch PVC pipes, and these are 3/4 inch PVC caps. And this is one of the 3-centimeter pieces in between, holding those 2 pieces together. It's called a close. And here's another one right here. Okay, so that's the frame. Now we're going to start wiring the frame for the ROV. I've already hooked up started running the wires for the other 2 motors, but now I want to do one to show you. Okay, so this is your motor, and then these are the wires that are coming off of it. There are 2 colors of wire. One is black and the other one is brown. The black will be your negative, will go to the negative terminal, the red will go to the positive. So we need to run the wires along the frame and try to keep things out of the way. So we're going to use these cable ties to tie everything down. So this first one is going to go over this 5-centimeter long section of PVC pipe. And you snug it down. Don't do it all the way tight yet, in case we have to move things around. Okay, so I have it cable tied there. I'm going to do another one right here in front of this, in front of the same T. Another one in front of this elbow. And just, we want to try to keep the wires either on top or maybe to the inside so it won't snag anything as we're running it in the water. At this corner of this elbow, we're going to put one diagonally across it to hold the wire. And then it's going to go back and behind this center post right here. The other two wires actually have coming from the other thruster on the left-hand side, and from the one going up and down are going to be on this side. This is going to run on the opposite side. So we're going to go around this post on this side. You can see where these had gone on the other side. And we're going to snug all this down with a cable tie. And just do it, just not hard, but just snug. Okay, so now we want to run the wires up. This thing right here, this is for the wire management. And before I told you that there was a slit in this 5-centimeter piece that goes down here. This is drilled up here, about 2 or 3 centimeters. This is a 1/4 inch drill, and then I just took the blade from the hacksaw and took it all the way down to the bottom. So this is the wires for this one that we're wiring right here, and we taped them together, and we're going to shove them up this pipe right here. So now the wire is coming up here. There it is. Okay, so put all the wires in the slot, and then we're going to use this green cap and push it on. So you can see all the wires now are tucked in there. And then this goes in, push back to here. And then we're going to put where all these wires go into this pipe right here. We're going to put another cable tie to cinch it, and that's going to be a strain relief for all these wires. And once that's done, then use a pair of diagonal cutters. Just tighten these up, cinch them down. And then use the diagonal cutters and cut off all the tails. Okay, so now we're going to try to connect it to the tether. And these are what we're going to need to do that. These are called heat shrink butt connectors with glue. And these are pink, and those are for 22 to 18 gauge wire. This is the wire that we'll be using. This is 18 gauge wire, and it has 6 pairs of wires in it. And I have them matched up like this. Now, this 18 gauge wire is actually braided wire. If you look at it really closely, it's not a single wire, but it's actually several wires. and that makes it much more flexible. So if you can take a look at that, you can see that it's actually several different strands in there. And if you can, you want to use that. I have seen people with these ROVs, especially if you're using the 500 gallon per hour pumps, is that you can use what's called Cat 5e cable, which is what they use for running for cable for LAN networks. The problem with that is Cat 5e cable is single strand. It's just a single wire. And if you use that, sooner or later, one of those wires will break. And if it breaks, that means one of the thrusters won't work. So if you use multi-strand, it will actually last longer. And the cable is actually much more flexible than with the Cat 5. So I have these in 3 different pairs. And the way I think of it is the red and the green go together because that's Christmas time. The brown and the black go together because that's actually each one of the wires that come off the bilge pump. They are black and brown. And then there's blue and white. And well, they're the remainders, but also I went to Penn State. The colors are blue and white. That's easy for me to remember. Now, with these color combinations, red, anytime you see a red wire, that's generally red wire. It's generally connected to the positive terminal, to the positive. Green normally goes to ground, sometimes called the negative. White generally will have power, so in this case we're going to use the blue for ground for the negative. And then on this one, on the bilge pump, it says actually on the wires, we'll say the brown is to be connected to the positive wire, black is going to be connected to the negative or to the ground. So we got to connect these to these 3 sets of wires right here. And I actually have coded these. These were the last ones we put in from over here. So this is going to be our red, this is going to be for our right thruster. This other one right here is going to be going to the left thruster, and this really long one is going to be going to the up down. And the reason it's so long is because it's so close. That's why this wire is long. Now we need to trim these wires down so we can use these butt connectors. So you're going to need to take notes whenever you do this. So this thruster right here, we're going to use the Christmas color. So that's going to be green and red, and the red is going to go to the brown wire for that thruster, and the green is going to go to the black wire. For the left thruster, let's use the blue and the white. So with the left one, the white is going to go to the brown wire, and the blue is going to go to the black wire. So that leaves for the up and down, we have black and brown. And the black wire is going to go to the black wire, and the brown is going to go to the brown wire. Okay, so we're going to need that. We're going to need to keep these notes whenever we actually start wiring the control box. So we need to strip off, about the 1.5 centimeters off of each of these. So using these wire strippers, we're going to go, since this is 18 gauge wire, we're going to go to 18 gauge on this stripper thing on the stripper handle right here. We stick out about 1.5 centimeters, and then we pull it, and there we are. Okay, so let's just do the next one, the blue and the white. Blue and white. And the black and brown. Again, we go to the 18 gauge. Okay, so we have that ready. Okay, now for these, we're going to trim this off, be roughly the same size as those. And we also got to go and strip these. So the black, this is, I believe this is going to be, let's see if it's 16 gauge. Yep. Just to make sure that these are going to fit. Yep. Okay, so this is for the center one. So I might go ahead and crimp this on. This is the black. And if you look in there, you can see the wire, and it's kind of bottoming out. So I actually need to trim this. I made this just a little bit too long. Okay, so now see the red tip of this? I'm going to go to the red there and then pinch it hard. Okay, so I'm going to take the black of this one, and I can tell already it's going to be a little bit too long. So I'm going to give it a twist it in the direction that the wires are twisted there, trim it back just a little bit. Stick the black in there. Make sure it's pushed in all the way, and then crimp it hard here. Okay, so here is the brown for the up and down one right here. Trim off, try about 1 centimeter this time. This is 16 gauge. Put on, oh, still a little bit too long. I just use the diagonal cutters on that, just it's quicker than try to use that the other tool. And it can be kind of hard to get that to go, to get the wire to go into the center of that. Okay, so I'm going to pinch it right here. And then this is going to go, tell already this is going to be too big. This is going to go to the brown here. What we're going to do next is use a heat source. This is a hair dryer, and I'm not sure if this will get hot enough, but we want to shrink these ends right here, and there's a little bit of glue in there, so this will shrink this down tight against these wires, and then it'll make it waterproof for going into fresh water. This will never work in salt water. Well, it needs to be done much differently and much more thoroughly to go in salt water, but this ROV is only going to be going in the fresh water. There, so now these are all heat shrunk and sealed, and this is ready to go. And you can actually see there's a little bit of glue in here, and it actually squeezes the glue out as it shrinks down. So this is done. Now what we're going to do now is this is one of that green cap, and we got to thread it down, and there's a 3/8 inch hole. So we got to thread this down. And jam a little bit of wires we have back in there. And what we're going to do is put a cable tie here on the top. Now all those heat butt connectors will act as a strain gauge on the inside. We're going to put this here, and we're going to put a dab of hot melt glue here, and actually right now the ROV proper, the ROV itself is finished. The only thing that I will do, I'm not going to show you, but I'll show you later on, is for each one of these connectors, I'm going to drill a 1/16 inch hole and put in a number 6 by 3/8 stainless steel screw in to hold all these pieces together. Now the reason I say a number 6 by 3/8 inches is because I can't do it in metric. These are US stainless steel screws. I got to use the US system for them. So these will be stainless steel, number 6. It gives this diameter, and the 3/8 is the length. So it's just going to be enough to hold this in. I don't want to use PVC glue, because then I can't modify things. One of the great things about this project with ROVs is now if you get it, you want to make a change, all you have to do is disassemble it and put longer or shorter pieces, make this any dimension you want to, add extra things. If I glued it, I cannot do any modification to it at all. So this is why I use stainless steel screws. So the next time you see the ROV, when we're ready to go in the water, it will have stainless steel screws holding everything on. Okay, so we're just about done with the electrical system, and we're going to be mounting the control box in this. This is a box you can get at Home Depot, and it had petitions in it for putting screws and nuts and bolts, and I took those out, and we're going to mount our switches in this. Now they have two models of this. This one is the polystyrene. It's clear. It's a little bit more rigid. They have a polyethylene one that's a little bit more opaque, but it's a little bit too soft, or so I think, for making it as a control box. Now I've already drilled the box. These two holes right here, these are in the center line of the box, and if you measure 5 centimeters from this edge right here to this point right there, put a mark 5 centimeters in from the edge and mark this point. You can mark it right there. And then I got a 1/4 inch drill and drilled where that point was, and then I went to a 5/16 and then a 3/8 and a half, making the hole bigger each time. So this hole's a 1/2 inch right here. You have to step up to it. You just can't go into the 1/2 inch because polystyrene can be kind of brittle, and you got to be very careful whenever you drill it. You have to do it very slowly and very carefully because it tends to grab and it might crack. This hole, again, these are 5 centimeters from this edge here to here, 5 centimeters from this hole to the center of this hole right here, and this was 7.5 centimeters from this point right here to the center, 7.5 to here. And then I just kind of eyeballed this one in between the two, halfway in between the two, and then just a little bit in from the end. And the other end, I drilled some more holes. This is in the dead center of the box, opposite the latch. There is, and I just eyeballed these. This is a 1/4 inch hole right here, and this one is a 3/8 inch hole. And both of them are just sort of in the middle right here. And the 3/8 hole, I actually did a 1/4, 5/16 and 3/8 in order to make those holes. So now we're going to wire this box up coming from the ROV. These are going to be the switches that we're going to be using. This is what's called a DPDT, or double position, double throw. And this switch, if you move the switch, and it's a momentary switch, so you hold it to this way, the switch will operate one way, you let it go, it turns itself off, and then whenever you go this way, it turns it in the opposite direction. And I'll show you how to wire it to make it this way. This is how we can use the thrusters for going forward and then for going backwards. Another reason I really like this switch is that whenever I build ROVs and I have, like whenever we have you know, displays, or I'm demonstrating this in the public, I'll have kids drive this thing, and sometimes you need to do some maintenance on the ROV. I don't want the blades to be spinning whenever I pick it up, because the blades spin very fast and you can cut yourself. And so I can just say hands off, and I know as soon as the hands are off that the switch will go to the off position automatically, and nothing will be running. Also, if you look at the switches, there's different sides and they have different writing. I always want to make sure that all my switches are going in the same direction, and so it makes it easier for troubleshooting when you try to get everything together. Here's a switch that's already wired, and if you notice on one side it said, I don't know if you can see this, but it says 25 amps, 125 volts AC. We're only going to be using 12 volts. The other side says something different. So what I do whenever I put these in the box is that I will mark the side that has the 25 amps on it. I'll put a mark right there, and then I'll put a mark on this end. And that way, all the switches will be put in the box in the exact same way, and it makes troubleshooting a whole lot easier. I got these switches from Marlon P. Jones. It's electronics warehouse out of West Palm Beach. I will have the data for ordering the switches there. And Marlon P. Jones has fantastic prices. This switch is only, I think it was $1.95. If you go to Amazon, it's a whole lot more expensive than that. The wiring that we're going to use for the inside, this is also I got from Home Depot. And this is what's called doorbell wire. And this wire is actually single strand copper. And this is 20 gauge. And if you can see that, it's just a single wire. And it makes wiring this so much easier, and I'll be showing you why. So this is the wire from the ROV, and we've already paired it up. Remember I asked you to take notes the last time. So the left thruster is the blue and white wire. The right thruster is the red and green wire. And then the up and down is the black and brown wire. Again, you can do it in any way you want, but just be consistent whenever you wire the thrusters. You want to be able to make sure we get it back together in order in the box. So this, and I already twisted these wires together. So this wire right here is going to be going into the 1/4 inch hole. This is about, I think 15 centimeters. I think I stripped about 15 centimeters off it, took the jacket off, and then put the wires together. So about 15 centimeters. Okay, so once it gets in, I'm going to put a cable tie just where the jacket is, just where the jacket starts. And snug it up really tight and cut the tail off. And then I'm going to pull it back until it's tight there, and I'm going to put another cable tie. And this is going to stop the wire from pulling out of the box. And then what we're going to do, after we get everything all done and all the wires tucked away, we're going to hot melt glue and kind of slobber this up so that it won't be able to move at all. Okay, that gets that wire in. Okay, so this is another wire, and this is the wire that's going to go to the 12-volt battery. I got this at West Marine. You can get it from Home Depot or whatever you want, wherever you want. Again, this is cut off about 15 centimeters right here, and this is going to go into the 3/8 inch hole. And again, using cable ties. I'm going to snug this really tight up against the end of the jacket. Right there. Cut off the tail. And then pull it back tight up against, and then put on another of these cable ties. This this cable I have, this 16 gauge wire that's going to go to the battery, it's about 4 meters long. So roughly about 12, 13 feet. Okay, so this is how it is right now in the box. Now we're going to cut off the tail. So again, we're going to slobber this up with hot melt glue to stop it from rotating around. We're going to set this aside for a moment. So these are 2 switches that I've already done, and these are marked, as I was saying, with those marks right there, so they're going to be oriented the same. So now I'm going to show you how to wire one of these up. So again, this has the 15 amp 125 volt AC right there. I'm trying to see where I can't see what's on the camera. This has some other writing which I can't really read, but this one, well, I forgot my marker, but this is the orientation I want. I would put a dot right there and a dot right there. So we're going to need to cut some wires. So you're going to need 2 wires that are 7 centimeters long, and then 4 wires, 2 red and 2 white, that are 13 centimeters long. And you're going to strip off about 1.5 centimeters on each end. I've already done that. So there's going to be a total of 2 13 centimeter wires that are red, 2 13 centimeter wires that are white, and then 1 white that's 7, and 1 red that's 7. Now this is 20 gauge wire, so on my wire strippers I'll use down here where it says 20, 22, and then strip off about a centimeter or so, 1.5 centimeters, and then here comes another one. Okay, so we're going to get going to get a screwdriver and loosen up these screws a little bit. They'll come already snug so that they don't fall out during shipping. Okay, so these are all loose now. And I have to mark this. It's really important that I mark this, you can see. So that's the 125 amp side right there. So I'll put a dot right here. Another dot right here. Okay, again, that's so that all the switches are oriented the same way. Okay, so looking at the back, the side opposite the end that has the dot, is that I see the white wire is going to go on the left and the red wire is going to go on the right. So, getting a pair of needle nose pliers, I'm going to bend this into, well, a semicircle. And I'm going to do the same for the other end. And I'm going to do that also for the red one. So that's how they are. So now for the switch, I am going to put this wire, one of the white wires, the one here on the right, and I'm going to put it so, see where the hook is, that as I tighten it, it actually tightens up the loop that I formed. If I do it the other way, as I tighten it, it will actually undo my loop and it might pop off the screw. Okay, so now I'm going to go and put the other loop, go across diagonally, and put it on this screw. And this one I'm just going to just slightly snug this side. Now back where I started, I want to crank that baby down. Okay, so it's down there tight. So now I'm going to go and do the red wire on the other side. Again, I put the loop on such as if I'm tightening it, it's going to actually tighten the loop as opposed to unwind that loop. Okay, and then it doesn't matter if you cross it over or under, but you have to go to the diagonal. So it's on this one, it's on the back left, so now I want it to go on the front right. And again, this one's going to be just done ever so lightly. Okay, so now we're going to do the two sides. Looking at how I did this, getting my dots lined up, is that I want to put the red wire on the right side and the white wire on the left side. So, working the red wire. Form my half a loop, and I'm going to crank this one down. And again, crank it down. This one, take one of these white wires, one of the bigger white wires, form this semicircular loop. Oh, it's a little bit too tight. Open it up. Oops. Remember I was telling you about doing it the right way? That was the wrong way. Okay, so as I tighten it, it's going to tighten that loop up. Okay, so going to the side that has the dot, again this orientation, we see the white wire comes here, red wire goes here. So we're going to add, this wire right here is going to go the same color. It's going to go the same color wire. So I have to loosen this one up. Remember, this is when I said don't quite, just do it snug but not tight. Undo that wire. Put this one also together so they share that same screw. Made that loop just a little bit too tight. Okay, so now that it's on there, now I'm going to snug it down tight. That's how it looks like from the bottom. This is where the dot is. We have these two whites will be on one side, these two reds will be on the other, and then we have this diagonal red and white. So we have 1, 2, 3 of these all done the same way. So we're going to go ahead and mount this in the box. Okay, so you want to have the wires facing away from you and the switch and the opening of the box facing you. So we're going to undo this nut right here, take off the switch plate cover, and then using either an adjustable wrench or a 15mm wrench. This switch is actually metric, it's not in American. You just tighten that nut down a little bit. And you're going to put the switch into the box such that the two wires that are going forward are going to be facing the wires that are coming in. So these are going to go, this switch is going to go like this. You're going to put the switch plate cover on. And you're going to put this nut on. And then you're going to tighten this. Now I'm actually holding the switch so it doesn't rotate. But the switch rotate it a little bit, try tightening it up a little bit more. There, you just snug it up really well. The switch is facing front to back, and your white dot's there. So this switch is going to be here. Now I'm just going to show you, I showed you this one, I'm going to go ahead and mount the other two in off camera. Okay guys, we're getting pretty close to getting done. I'm getting pretty excited. Okay, so we have our switches here mounted, and I have them such as the wires are facing forward. There's the red on the left, white on the right, red on the left, white on the right, red on the left, white on the right. And then for going up, these one comes from the middle of the switch. The red on the left, white, red left, white right, and left red, white right. So what I haven't done is stripped off the wires on the switch that we just wired. So I'm going to take about centimeter and a half off of each one. Again, this is 20 gauge wire, so I'm using the 20 gauge on the scrubbers. Okay, so red on the left, white on the right, for the middle, for those facing forward. Okay, so from the front of the box, this is the left and the right, up and down. The left thruster is this one right here. So remember we took notes. So the left one is the blue wire was for the black, so the blue wire gets negative. So we got to strip. This is the power wire coming in from the battery. This is 16 gauge. Give these a twist. Okay, so the left wire is the blue and the black and the white one. So we grab this one right here, unwrap a little bit, and according to this one, the blue went to the black wire, which was negative. So we'll put the white wire together, and just because this is temporary, because we're trying to see if we have it wired correctly, we put the blue to the white of the switch, and we're going to use this blue wire nut, put over it, and twist it clockwise. And the white we're going to use with the red. You just line them up next to each other. Get a blue wire nut. The blue wire nuts are the smallest ones, and they go together like that. So the up and down is wired just like the motors for the wires that come there, this blue and the black. So on this blue and black pair right here, we know that the red is supposed to go to the positive of the motor. We'll take this red one right here, put them next to each other, right up so they're the same length, using one of these blue wire nuts. Twist it on, and you keep twisting until they're jammed on and you can't twist it anymore. And so the black is going to be going to the white. I know it's kind of confusing with the different colors of wires. That's why you need to write things down. And even if you try to write it down, I'm positive that I will have messed up somewhere in this video. But by using wire nuts, we can go and undo things and make it correct. And then at the end, we'll make these, instead of using wire nuts, we'll make them permanent. If you do do the MATE-ROV competition, is that they have rules, safety rules about how things have to be wired and stuff like that. You have to do it their way. But this is just for us right now to do some troubleshooting to see if we did everything correctly. Okay, so the last one we have to do is the right thruster. Remember, that was the Christmas, we called it Christmas, the green and the red. The right one is the green one went to the black's negative. So, and on this wiring from the switch, we're going to put the green on the white, blue wire nut, twist them on, and the red goes with the red. And that's where they're going to be the positive wire. Okay, so now we have the switches wired, but now we got to get power to the switches. And we have, there's a red wire that goes to the middle of each one of these, and then the white one. So we're going to use this red wire, because the red wire will definitely, from this one, from the battery, will definitely go on the positive. And we'll probably be using, I'm not sure if it's going to be the orange or the yellow. So you get all the reds, and these are the wires again that come from the middle of the switches. All the reds go together. Kind of give them a twist together. Then this red goes up alongside. And all of them are going to get twisted. I think we're going to need this yellow. And use the wire nuts to join them all together. Make sure that you put the wire nut on tight. So that leaves the white wires, and we're going to hook the negative up to it, so get all the white wires together. Line them up. Put the black wire together. And then get another of these yellow wire nuts and twist that wire nut on and tuck everything in and close the box. Now, if you look in there, it looks kind of a mess, but make sure that you have no bare wires that are sticking out, that everything is held in there tight. And then clamp everything down. Okay, so now we're going to hot melt glue these cables so they don't rotate like that. So we're going to use this hot melt glue, and we're going to put, kind of slob it up there. Goober it, slobber it, whatever you want to call it, so that it doesn't move around. So put some here on the outside, and we'll put some on the inside as well. Okay, so I'll let that set for a second, and then we'll hot melt glue the inside. Okay, so now I need to put some of this hot melt glue here to the inside so the wires don't pull around, don't rotate, and to lock the cable ties on. So we're just going to slobber some of this stuff in there. And won't take it nearly as much. We just want to try to isolate everything, try to make so the cable ties won't slip off. You can't really rush the hot melt glue drying. You want to make sure that it stays rigid. But we're just about done. I'm getting pretty excited here. The only thing left to do is to put the ends for the cable on for that goes onto the battery. Okay, so now we're ready to put on the battery clip ends for the ROV. So the first thing you need to do is to do the negative terminal. I've already taken off this black insulator and slid it up the wire. Might have to twist the ends. And then once you get it to where the wire pinch spot is, go ahead and fold those dog ears over to cinch the wire into position. And then you can see where that wire is. Pinch that little tab in there. Well, I'm going to have to end up coming up and solder these to get a good electrical connection. So that's done. Now we need to put a fuse on this. So I've already put the fuse on. It's already been pinched on. But I want the two wires to end up being about the same length. Slide this out of the way. So what I need to do is to cut this wire off about here, such as with this fuse in line, it'll be the same length. This is 16 gauge wire, using the 16 on the strip gauge. Do, I don't know, about 1.5 centimeters. Twist it. And then I've already got the butt connector. This is a blue one. This is for a little bit bigger wires than what we were using before. Insert this to what goes inside this metal sleeve in there. This is just a little bit too long. And then now we're going to be using the blue dot side here. We're going to pinch it. Pinch this side. And then we're going to use the heat shrink gun, the heat gun, and shrink this down. Again, there's glue in there, so once it shrinks down, glue will seal it so water can't get in. Okay, so I just hooked it up to a battery, and get this out of the way. Okay, so I'm going to hit the switch for the starboard engine. Ooh. Got the wrong side there. Okay, so remember I was saying about we're going to use wire nuts so we can get everything straightened out? Well, this is one of those straightened out. I got wires. I got the two wrong wires on the wrong ones. So that one works this way. It works backwards. This one works this way. It works backwards, but I'm using the wrong one. It should be, when I push this right button forward, this right one come on, and then the up and down. Okay, so what I found out was that I have the left and the right ones are wired to the wrong switches. So now we're going to go back and change them. Okay, so I have the box open, and these are the two that are miswired. This is the blue and white one. I have them over here. And the red and green ones are over here. So I need to switch these. First I need to disconnect power to the battery. So I'm going to untwist these. Untwist these. And the blue and the white are going to go over here, and the green and the red are going to go over here. Okay, so on this one, the red and red are going to go together. Put on the wire nut. The green and the white are going to go together. Put on the wire nut. And this one, we need to go back to our diagram, our thing. And the blue and the white. The blue is negative, so it's going to go to the white here. And the white is going to go to the red over here. Again, I know it's confusing with all the colors, but we switched wires twice on the way to the switch. So that's why it's important to write this down, and then using wire nuts to get everything all straightened out to make it temporary. Okay, so now that we got rewired, and this should be the right one right here. Oops, I forgot to connect the battery. Now also, I am wearing safety glasses. I do that as a matter of work. I work all the time. Whenever you are working around these propellers or energizing anything, you should always wear safety glasses. They can be very inexpensive at Home Depot, like $2 or $3, or you can get more expensive ones, because these are very high speed and sharp, and if the bolts aren't on tight, things could fly off. Also, these blades are very, very sharp. Eventually, you're going to need to put a shroud over it so that you don't get a finger in there, because again, you can cut yourself very badly. But this is not showing you how to go. This is just getting you an RV in the water, and you have to do your own safety. Okay, so this is the right one, and we got correct rotation. The left one, and the up. Okay, actually, this is backwards. Whenever I push what should be up, it's going down. So we're going to make another change. Again, because we have the wire nuts, we can do these very, very quickly. Okay, so we're going to pop this open. And if you remember, the black and the brown are the up and down. So here's the black and the brown. So we just need to change which wires go where. So we'll disconnect so we had the brown going to the red. We're going to have the brown going to the white. And now we're going to have the black going to red. Again, this is kind of confusing, and generally you don't do black to red, but because we're just using the colors that are available in the power in the 18 gauge 6 wire, and so this isn't, this is kind of non-standard, but those are the colors that were available in the box. So, oops, battery back connected. Right, left, up. All right, we are just about ready to put this in the water. Okay, before we leave to go out to the pool, I just want to point out something I just did. I wasn't very happy with the way the wires were with these wires exposed here. So what I did was I doing a little thing better to stop strain on these wires. I put a cable tie here to cinch down on the jacket of this wire here. I ran it underneath and put another cable tie here. I put a cable tie right here where it comes up in front of the post, and here I did an X and put this on both sides, such as now if there's any tension on the cable, it won't be transmitted to this and it won't be pulling the wires out of the motors. So it's just a way of managing the wires. I'm not sure if this would be legal for the MATE-ROV competition. I know if you would buy a kit from them that has everything you see here except for the PVC frame parts, but has the motors and everything like this, is that they actually send you these what's called a strain relief, which is a better way to manage the cable. But I'm just trying to make something that you can do locally and a little bit cheaper. It would certainly be more convenient to order it from MATE-ROV, but this is a cheaper way, and it's a very good way also. I also added some screws here where these different fittings go. I will add more all the way around whenever I'm satisfied that this is right, and I'll also be drilling 1/4-inch holes in these elbows such that whenever we put it in the water, the frame will flood. You don't want air bubbles in there because it'll affect, and if some water gets in, it will behave differently, but I will mention that later. But right now, I want to get this in the water and see how it works. Okay, to make it go forward, push the right button forward, and the left switch forward, goes forward. To make it go backwards, you push the right one back and the left one back. To make it turn to the right, you just turn the left switch or the left thruster. Turns it to the left. Make it turn to the right. Just turn to the right. If you want it to turn very quickly, you put one forward and one back. Make it go the other way real quick, forward and back. And to make it go up and down, this goes up. And then I usually keep these negatively buoyant, but if you want it to go down fast, you can just put the switch back. It makes it go down fast. And that's all there is to driving this little ROV. And with a few modifications, it could compete in the scout class with the MATE-ROV competition.